Hi, I'm James Ellerby. I am a student in the thesis School of Computer Science at Columbus State University in Columbus, Georgia. I'm in the Applied Computer Science Master's track with a concentration in traditional.
Hey, my name is Yujing, and I'm also in Columbus State University, study computer science, concentrate in software development.
So a little bit of introduction of what our project is about. Eugene and I were working on a separate project in our algorithms course, where we were selecting a topic in algorithms, and we choose an algorithm to analyze, and we chose a class of graph algorithms, and then we saw that we could come into this conference, or we could enter a project into this conference, and we thought, well, what if we created a tool to visualize graph structures and the related algorithms? So graph structures and algorithms are typically introduced in data structures right after the linked structures, and then the advanced graph concepts are then introduced in also discrete mathematics, which is one of the required courses in our program. So why should we create a tool? Well, any data structure students usually typically have trouble with the linked data structures. They're hard to visualize, and then the algorithms can be numerous and confusing to keep track of how to execute an algorithm, how to implement it, and just making sure you understand the difference between them. And we also want to improve on already existing tools, and we'll talk more about this in the related work section of our presentation. So,
All right. So as James elaborates, there are a lot of students are having the problem to understand the mechanism behind algorithms, especially for graph algorithms. So graph algorithms have gained a huge amount of popularity over the years. So for example, for a single graph problem like the shortest path finding problem, we can have so many graph algorithms can be applied to this specific problem. For instance, we have the most well-known Dijkstra algorithm, and we also have the Bellman-4 algorithms. They are both used for single source path finding problems. And we also have the Floyd-Warshel for finding the path uh, for uh, for all of the nodes in the graph to all other nodes in the graph. So it's basically many-to-many algorithm. So our first goal of this project is trying to elaborate some of the most popular graph algorithms, including all of the shortest path finding algorithms that I just talked about. And we also will cover some of the most popular algorithms like the breadth first search and depth first search in our research project, which are some of the most popular algorithms for the graph traversal. And from there, our second goal is trying to create the visualization tools for these graph algorithms. So our aim is trying to create these tools for open source community and hope that we can bring the greatest free tools that is highly accessible for the computer science freshmen and many other mathematics students who are currently learning the graph data structures, discrete math, and typological problems, as well as their corresponding algorithms. So one thing to know that is that the number of the algorithms are not limited. As our project being implemented and grows, we will add more and more algorithms to this project in the future. And next slide, please. So for our visualization tools, it will be completely hosted online using the web services. Our initial plan is to use React as our front end framework. So React makes creating our interactive UI much easier. And the React engine behind the scene is able to efficiently update and render the web page corresponding to any change of our graph data structure. So because React views are declarative, which means that the UI will always reflecting the data structure. The code logic doesn't have to go there empirically to go to the DOM to change the UI. And for the backend side, our initial idea is trying to not store any data in our backend server because the graph structure will be completely composed by the user, by user's input. That also will simplify our project a little bit. And lastly, we are also planning to use some of the popular visualization tools and animation JavaScript libraries. We don't want to reinventing the wheels. That can be hard, and we would rather to take the advantage of those useful libraries. And here are two libraries candidates. One is called D3.js, and another one is called Vis.js. Both of them are JavaScript visualization libraries, which make our implementations much simple and also significantly shorten the product delivery time. And next slide, please. And here is some basic features and functionalities that we initially proposed. First of all, we will have a palette in our web app. From there, the user will be able to select what can be added to this graph. For example, the vertices and the edge of the graph, or the user can also add in the weight to each edge of the graph. And secondly, we will also have something like the drop-down menu that allows the user to select what graph algorithms to be used for execution or visualization. And last but not the least, we will also offer the user the options to generate the code from the graph. So by offering this feature, users who wish to construct the graph programmatically could be able to do so. Also, it can show the users the graph, how the graph could be written in code. And we haven't decided what programming languages are going to be used for generating the code, but we were probably trying to include as many options as we could. And next slides. So now let's talk about some of the related works. Here is a pathfinding visualizer by Mr. Clement. So you can click the link to go to the demonstration. Okay, so this visualizer has a great layout. And from here, we can basically pick a random layout. Basically, the user also can create any cell within a grid trying to make a word and to cut the path. The user can also select any shortest path algorithms that he offers from here. And the graph is totally configurable. And from here, you can just visualize the DFS. And then the algorithm will find the shortest path by using this algorithm. All right, cool. So back to our slides. So our project is very similar to this project. We will provide the user the full compatibility of the customization, and the nice animations and the intuitive user interface and the user experience will be applied to our project as well. However, there are a few things that we think we can improve from this work. The most important one is that our visualization tools will be responsible so that it can run on any mobile devices. Another thing is that our project our target audience is computer science students and educators. So we are not trying to implement the grid layout as he does, but instead we are trying to implement the vertices in more traditional ways. And next, I want to hand it back to James to talk more about some related works.
Thank you, Eugene. The first related works the next related works we have is the Bridges project by the University of North Carolina in Charlotte. So this one, it allows the CS students who are taking data structures to um, more programmatically create their graphs and then visualize them. And then we won't have a demonstration of this project simply because showing off code and calls to the API would be too complex. However, we did want to highlight this as a related works because it requires programming in C++, Java, or Python. It can be used as a tool to learn various linked data structures and not only graphs. So, and how our tool is similar to this is the data structure visualization, although ours is focused on the graph structure, and our project serves as a tool to learn this graph data structure. How we plan for our tool to differ from this one is responsive and accessible from web browsers, um, and all of it's done through this canvas idea where the student can interact with the pat pay the panel consisting of the edges and vertices they can add to the canvas. It'll require no programming or API access, which makes it super accessible to students wanting to just simply visualize and set up a graph. And we'll also incorporate algorithms visualization. The bridges is simply data structure visualization. Our project will incorporate the algorithms visualization. And then, as I've said, we're focusing on graph structures. So here's another tool that we found that is mostly related to our project. This allows you to um, create your graph and visualize some algorithm on it. It's an accessible dynamic web app, and there's a large list of supported graph algorithms. I will now demonstrate one. So we could choose for a shortest path algorithm like Dijkstra's, right? And then we can select two, and then and we can show us visualize the shortest path on a graph that the user has created. So sorry, let me just get back to the slide. That's interesting. Sorry about that. I lost the presentation. Okay, so we wanted to highlight this tool because I believe this tool is the most like what we were envisioning. So our tool is similar because we also plan for it to be an accessible dynamic web app, and we also plan to support a large number of graph algorithms. And so some of the improvements we want to make on this tool are we want to improve on the interactive side of it. So like maybe try to improve on the interface somehow. Like make it maybe like a click and drag. Just remove as many um, as many paths or walls, if you will, from the user, so it's frictionless interaction. And as Eugene mentioned in our previous proposed features, we would like to incorporate this code panel where you could visualize programmatically how the graph and algorithm might be implemented in some code. So I will now hand it back to Eugene to talk about our conclusion.
All right, thank you, Joey. So in conclusion, our project will have computer science students and the mathematics students, as well as the educators, better understand our graph algorithms. So far, we have discovered some of the potential limitations for this project. So first, some framework or libraries that we just talked about might might not be the most appropriate ones, and we will shape our plan as we meet more issues with those frameworks. And our second one, Our second difficulty is trying to make the most intuitive UI for both the desktop and the mobile devices. That can be hard to do. Many layout details have to be considered before we start implementing our web app. And some CSS framework like Bootstrap might be used for the layout purpose for our web app. And the last issue is the limitation of our small team. Currently, we only have 2 students participate in this project, and both of us are full-time students. This project will take a long development time to be finished. And finally, we want to talk about our future work as well. Since we just planned out our blueprint for this project, first work that we need to do, of course, is to begin the development process. After we have a prototype of what we expected, we will start to add more and more algorithms to our app, and also continuously improve the user interface and the design of our app. And that is all for us. All right, thank you all. All right,